So I'm drawing the diagram, then afterwards explanation will be there. That's why. So I consider elemental rectangular block. Generally, you are going to consider a cube, but I taken as about now. Yesterday, I considered about a triaxial state of stress with a cube, but I taken a rectangular block here now. Now, which shear stress you have to call it this now? Is a which phase now? X phase. Tau xy. This is tau xy. What the area of this phase now? dy and dz. dy and dz. Now, this is y phase. Y phase. What the area of this phase now? dx and dz. dx and dz. Now, the resisting shear force due to this now. I'm assuming the resisting shear force due to this one F1. But this force in which direction? Now y direction. So if the sum of the force in y direction should be 0, always you are assuming the equilibrium condition. Let F1 is the shear force due to tau xy. Shear force due to tau xy. How to get this now? Stress multiplied by area. What the area of this face now? Shear force due to tau xy. This force in which direction? Y direction. Upward will be there now. So if the sum of the force in y direction should be 0, so this force is in upward direction. Y direction. So for equilibrium, sum of the force in y direction should be 0. Then we need a force in downward direction. This force I am getting upward. This force I am getting upward. In which direction? Upward y direction. If the sum of the force in y direction should be 0, we need a downward force is required. Now these two are of the same area, different area. These two are of the same area. Sum of the force in y direction should be 0. So we need a one force in the downward direction. But these two areas are same. When the areas are same, force should be same. Then, so stress should be same now. So here you are going to get a this is what now? Tau xy. Now sum of the force are 0. These two areas are same. Areas are same. And this force should be same, means automatically stress should be same now. Stresses should be same. This force and this force should be same. And already what the areas are same, then automatically stress should be same. Now because this one what happens now? Sum of the force are 0. Sum of the horizontal force 0, sum of the vertical force 0. Now with respect to forces, equilibrium now. Now these two forces, what they are going to form now? A couple. These two will form a couple in which plane now? These two will form a couple. This force P F1, F1 dash, both are in what now? Equal. They will form a couple in which direction now? Anti-clockwise. In which plane now? Vertical plane. These two can be seen in which plane now? Vertical plane. Vertical plane means which axis now? About z axis. Coupled due to tau xy, that is What's the distance between these two now? Dx. Now these two will form a couple in which plane now? Vertical plane in anti-clockwise direction. So this I am taking the negative Cz. C1 I am calling now. How to get a couple now? Force multiplied by perpendicular distance. That is F1 into dx. Since this couple is in anti-clockwise direction, I am taking as a negative. What the F1 value now? What's the meaning of negative? This is anti-clockwise direction. Now already what the sum of the horizontal force 0. Sum of the horizontal force 0, sum of the vertical force 0. But some of the couples are not 0. We need to get it what? One couple only got it now. This couple is in which plane now? Vertical plane. Vertical plane which axis perpendicular? Z axis perpendicular. Now if the sum of the couples should be 0, is already sum of the force are 0. Sum of the horizontal force 0, sum of the vertical force 0. But sum of the couples are not 0. If the sum of the couples should be 0, that is what now? Couple in vertical plane. We are getting only one couple we are getting in anti-clockwise. So if the sum of the couples should be 0 means we need a anti-clockwise. This is already anti-clockwise. Then we need a clockwise couple is required. Then we are going to get a now this will what now? Tau yx. This will give a couple in which direction now? Clockwise. This will give a couple in clockwise. This is a complementary shear stress. This is tau yx. Tau yx. Now what the force due to this now? Now due to this one you are getting a force in which direction now? Now, so why you are getting this now? If the sum of the couple should be 0. If this is not there now, if this will not exist, what happens now? It is not in equilibrium. Sum of the couple will not be 0. If there is no tau yx, so the tau yx is required what now? If the sum of the couple should be 0. Now this force is in which direction? X direction. This force is F2. Shear force due to tau yx. Now to get this value now. Tau yx multiply area of the y face. What the area of the y face now? Now this is which side now? Towards right side. Now sum of the force are not 0 now. Because of this one what happens now? Why you are introduced now? The sum of the couple should be 0. But because of this one what happens now? Sum of the horizontal force not 0. Now if the sum of the horizontal force should be 0, we need a one more force which side now? Towards left side. So if the sum of the forces should be 0. So now we are going to get a one more force here now. But once again these two are same area. Areas are same. This force and this force should be same. F2 and F2 dash should be same. F2 and F2 dash should be same. But they are opposite direction. Already what now? Areas are them. Once again here stress should be same now. So this is what now? this is tau yx, tau yx. Now because this one what happens now, sum of the force are 0. Because this one what happens now, sum of the force are 0. Which force are 0? No, horizontal force 0. Because this one what happens now, sum of the vertical force 0. And because this one sum of the horizontal force 0. If this is not there, what happens now, sum of the horizontal force is not 0. Now these two will form a couple. Now CZ, this couple I am calling C2, coupled due to tau yx. This couple is also in which plane? Now vertical plane. F2. F2 dash. F2 dash equal to F2. What the perpendicular distance between these? No, dy. So once again these two will form a couple in which plane? Now vertical plane, but the clockwise. So how to get this couple value now? CZ is equal to C2, which is equal to this couple is a positive. So F2 into dy. F2 into dy. Now this is in vertical plane, but in which direction? Now clockwise. Now finally sum of the couples should be 0. For static equilibrium equation now, that is C1 plus C2 should be 0. That is equal to C1 is equal to minus of C2. But the C1 value got it now. But the C2 now. So we got this relation by using which equation now? Sum of the couples are 0. That's why what now? Somebody says, sir, you are not getting a minus sign because they are already in opposite direction. Opposite direction. That's why yesterday studied what now? Every shear stress should be associated with a complementary shear stress. How we got this relation now? How we got this relation? By using the sum of the couples should be 0. In which plane now? Vertical plane. Same thing, you take the sum of the couples in horizontal plane by using the what now? This is the sum of the couple, but this you got it by using that is in vertical plane. Similarly, sum of the couples in horizontal plane, that is by using sigma y is equal to 0. You are going to get it tau xz equal to tau zx. Similarly, by using the sum of the couples in profile plane, that is sum of the couple about x-axis equal to 0, then you are going to get the tau y z equal to tau zy. So by chance I kept this towards left side, what happens now? If they're towards left side, this is going to be towards right side. Now this also form a couple in which direction? Anti-clockwise. Suppose I have taken this towards right side I have taken. Suppose somebody is going to take the towards left side. This will be towards right side. Now once again this also form a couple in negative direction. Anti-clockwise. Then it is going to become as minus now. Then you are going to get the minus, you are going to get it. Here I am not getting the minus because they are already in opposite direction. These two are what now? This is forming a couple in anti-clockwise. This is forming a couple in clockwise. So similarly, So at the junction there will be one value. They are going to cross it now. This is the tau xy, this is the tau yx. So what the tau xy value now? Tau, but the negative or positive? No, negative, minus. And what about the tau yx also tau? This is going to be clockwise. So if I have written this, what some numerical value is going to be there now that I have written as a tau. So what the tau xy minus tau? What the value now? Value is tau, but direction is what anti-clock. Therefore tau xy equal to minus tau, and this is the tau yx. This is what now plus now. That's why you are going to show like this now. Tau yx is equal to minus tau. That is so whenever you are showing the complementary shear stresses, you have to show such that they should cross with each other. I mean they will form a couple in opposite direction. And at the junction there should be only one value. Only in this case the sum of the couple should be 0. Every shear stress should be associated with a complementary shear stress of equal magnitude, unlike in nature. If sum of couples in that plane should become zero, should become that is with respect to couple equilibrium equation. Static equilibrium equation. Complementary shear stress are also known as cross shears. State of stress should be in such a way that point should be under static equilibrium condition. Static equilibrium under static equilibrium. How many equilibrium equation in 3D? Triaxial. Six equations are going to be there now, but in 2D, that is the biaxial case. Mostly you are dealing with the 2D. Square and symmetric matrix. Should be a square and symmetric matrix. Symmetry of stress tensor. Is obtained. by using couple or moment static equilibrium equation. Obtained by using couple or moment equilibrium equation. For a point under triaxial state of stress, number of stress components stress tensor are R9. Three normal, six shear stresses. For a point under biaxial state of stress, are 4. To define the triaxial state of stress, number of stress components in stress tensor. To define means you have to go for independent components. To define triaxial state of stress, to define triaxial state of stress are independent. Now same thing for biaxial, write down now. Number of stress components in a stress tensor. Default we ask what the total you have, but if you have mentioned the define means you have to go for independent component 6. But same thing for biaxial, you have to go for 3. Sigma x, sigma y and tau xy. In a stress tensor, the same thing is also valid for the strain tensor. Whatever you have studied in the stress tensor, same thing it is also valid for the strain tensor, also is valid the same. Plane stress or 2D or biaxial state of stress problems. Sometimes the triaxial state of stress problem is also assumed as a biaxial. Triaxial state of stress problem is also assumed as a biaxial state of stress problem. But what is the condition now? If you want to assume the triaxial as a biaxial state of stress now, if the stresses in one of the perpendicular direction are very smaller in magnitude in comparison to stress in other two direction. Triaxial means stress are developed in three perpendicular planes. But that problem should be assumed as a biaxial. Then what the condition now? Stresses in one of the mutual perpendicular direction. Stresses in one of the mutual perpendicular direction. One of the mutual perpendicular direction, or one of the mutual perpendicular direction should be smaller in magnitude in comparison to the stresses developed in the other two perpendicular now. Suppose the stress in the z direction is what? A very small in comparison to x and y. It is neglected. Then we consider the biaxial. Actually the triaxial only. Then the pressure vessels are triaxial only. Due to pressure vessel, when a fluid is stored in a pressure vessel, you are going to get the three stresses: hoop stress, longitudinal stress, as well as the radial stress. But in thin pressure vessels, the radial stress is neglected because of what? It is smaller in magnitude in comparison to hoop and longitudinal stress. Hoop and longitudinal stress. So whenever you want to consider triaxial problem as a biaxial, so stresses in one of the mutual perpendicular direction should be very smaller in magnitude in comparison to stresses developed in the other two perpendicular direction. That is when compared to x and y. But what is the condition now? If the stress in one direction should be very small, other two directions should be very large. There are two conditions are going to be there. One is a what now? Geometry condition. One is a loading condition. What the geometry means what now? One of the dimensions should be very small. One of the dimensions should be very small in comparison to other two dimensions. One dimension should be very small. If you take this board example, board what now? Height is more, width is more, but thickness is small. Similarly, if you consider the workbook, length is more, width is more, thickness is small. Just like a sheet metal, thin sheet metals. Pressure vessel, thin pressure vessel, length is more than diameter, but diameter is what? More than the thickness. In thin pressure vessel, diameter is minimum 20 times the thickness will be there. So whenever triaxial problem should be assumed as a biaxial problem, that is when the stress in one direction should be very small in comparison to stress in other two direction. First condition should be what now? One dimension should be very small in comparison to other two dimensions. Examples are board example, sheet metal example, as well as pressure vessel, flywheels. These are all what now? Two dimensions are very larger and third dimension is what? A very smaller. Next, the loading should be in such a way that stress depend upon the load or dimension both now. So loading should be in such a way that the stresses developed in the smaller dimension direction should be smaller in comparison to the stresses developed in the larger dimension direction. Loading should be in such a way that the stresses developed in the smaller dimension direction should be very smaller in magnitude in comparison to the stresses developed in the larger dimension direction. So in pressure vessel, radial stress is very small. It is developed in the thickness direction. Radial stress equal to pressure. Thin pressure vessel means what? A thickness is less. Then they are able to withstand the less pressure. When the pressure is less means radial stress is less. So the radial stress smaller in magnitude in comparison to hoop and longitudinal stress. Therefore it is neglected. We are going to consider biaxial. In the entire syllabus, only in pressure vessel we are getting a triaxial. As per your syllabus now, we are getting pressure vessel is a triaxial. But the thin pressure vessel you are assuming as a biaxial. Even though the triaxial you are assuming as a biaxial because of radial stress is very small. Why the radial stress is very small? Pressure is very small. Why the pressure is very small? Thickness is going to be less now. But if you go for a thick pressure vessel, thick pressure vessels, they are used to store the fluid under higher pressure. So when the thickness is more, automatically what the fluid pressure is more, then radial stress also more. Radial stress always equal to pressure. So since the thickness is more, fluid pressure is more, then radial stress is more. Then it cannot be neglected. But in thin pressure vessel, hoop and longitudinal stress are very smaller in magnitude in comparison to radial stress. It is neglected. So always about a pressure vessel, is it may be a thin or thick, always the triaxial. Stress are developed in the three perpendicular direction. But thin pressure vessel is assumed as a biaxial state of stress because the radial stress is going to be very small. For that one, two condition. One dimension should be very small and other one is loading should be in such a way that stress in the smaller dimension should be smaller in magnitude, stresses develop in the larger dimension directions. So that only about a plane stress or 2D or biaxial state of stress problem. Are those problems? Are those problems in which stresses developed in one mutual perpendicular direction or one mutual perpendicular plane, develop in one mutual perpendicular direction are assumed as zero. Assumed as zero means what the meaning? No, as zero or non-zero? Assumed as zero means they are non-zero but we are assuming as zero. Why you are assuming zero? Because they are very small now. Whenever you are neglecting means they are very smaller in comparison to other now. So assumed as zero. That is they are smaller in magnitude. Smaller in magnitude in comparison to in other two perpendicular direction. For example, if stresses in are smaller in magnitude in comparison to then how many are going to be assumed as 0? Z direction what now? Z direction how many stress are there now? Sigma Z, tau YZ and tau XZ. Z direction sigma Z, tau YZ, tau ZX, tau XZ. This is according to the no. But tau YZ 0 means what now? Tau ZY is also 0 now. Complementary shear stress are equal unlike this is according to the assumption Z direction. Tau YZ 0 means automatically tau ZY is 0. Tau XZ is very small means tau ZX is also 0. So total how many will become 0 now? Total 5 will become 0. Then you are going to get only 2 by 2 matrix. That is about a sigma x, sigma y, tau x1 and tau yx. You are going to get it. In Z direction they are very small. So they are when compared to stress in x and y. So these they are neglected. Then when tau yz is very small means tau zy is very small. Tau xz is also very small means tau zx also very small. So total 5 component will become 0. Then left out with only 4 component. The size of the matrix is going to be 2 by 2 matrix. But when this is possible now? Condition for plane stress problems. Loading condition. Okay, you can also treat it as what now? Your smartphone also you can consider now. Mr. Swaraj Pandey is given the what now? Sir's mobile phone also can be, smartphone also can be considered now. Or even if your laptop nowadays you are getting the what now? Laptops also what are very thin. Geometry and loading condition. What is the meaning of this now? The geometry. Generally you are going to get a three dimensions are going to be solid means you will have the 3 dimensions now. So one dimension should be very small in comparison to 2 other dimensions. Geometry of the component or a member. Should be in such a way that one dimension, one dimension, one dimension should be very smaller. In comparison to the already I give an example, this board example, wall example. Even if you take the walls also, what now? Length is more, height is more, but thickness of the wall is less. Length and height are in meters, but thickness in will be there. Sheet metal and your laptops as well as what the mobile phones and thin pressure vessels and flywheel examples now. And what the second condition now? Loading should be in such a way that stresses developed in smaller dimension direction. Smaller in magnitude. In comparison to stresses developed in larger dimension directions. Every year I am going to discuss, but only in one of the gate paper directly the question is given based upon these conditions now. That question also there in the workbook. So today I am going to give that what directly can solve that question now. Never there is only one time this question is given, but every year I am going to discuss this now. But who's thorough with this condition, they answered that question now. We'll take example. With the example also I explain this now. These two conditions, how your triaxial problem will become the biaxial problem. Strain tensor. As per your syllabus, you are having only stress analysis. What you have studied the first day, stress is determined or strain is determined theoretically. Theoretically, stress is determined. Strengthometer subject is a theoretical subject. Strain is determined experimentally. But we want to determine the strain theoretically. What you have studied, now we need a elastic constants. So your syllabus having only strain analysis is there. Strain analysis there, stress analysis. We are having only stress analysis there. strain analysis not included in the syllabus now, but still your GATE and ESC you are getting the strain analysis questions you are getting. BTech syllabus having only stress analysis. Strain analysis not included in the syllabus now. My dear friend, I have already mentioned, please try to have some patience. I have already mentioned what now. Try to everybody is going to get a doubt. That's why I'm going to take an example. I'm going to explain it now. So now strain analysis is not as per the syllabus, but you are getting the question GATE and ESC on the strain analysis. Then how the student has to do it now? Strain analysis similar to stress analysis. If a student know the stress equation, that if you know the equation for the principal stresses and normal stress and shear stress and oblique plane equation, the same thing you can write down for the strain analysis now. Can be written for strain analysis. What change you have to make it now? All the strain analysis equation you are not deriving now, but directly can write down now. The derivation of all the strain analysis equation is going to be generally MTech level will be there now. But in the BTech level, how you are doing this analysis question now? If a student remember the stress analysis equation, strain analysis equation directly can write down. What the change you have to make it now? Wherever normal stress is there, that should be replaced by epsilon, corresponding epsilon. If sigma x is there, it should be replaced by epsilon x, sigma y by epsilon y. But wherever shear stress is there, that should be replaced by half of the shear strain, half of the shear strain. Now if you know the stress tensor, along the diagonal what you have written now? Along the diagonal you have taken sigma x, sigma y, sigma z. Now when you are writing the strain tensor, what I have to take it now? Wherever sigma, I have to write down the epsilon. Epsilon x, epsilon y, epsilon z. And what the first row you have taken now? Sigma x, tau x y and tau x z. Wherever tau is there, you have to replace by gamma by 2. Means first row is going to be what now? Gamma xy by 2, gamma xz by 2. Now all the strain equation, we are going to derive the equation for stress, but all the strain equation directly the student can write down. Simply what he has to do it now? Only he has to remember one statement is what now? Normal stress should be replaced by corresponding normal strain. That is sigma x should be replaced by epsilon x, sigma y by epsilon y, sigma z by epsilon z, and shear stress should be replaced by half of the corresponding shear strain, half of the corresponding shear strain. That is tau xy should be replaced by what now? Gamma xy by 2. Tau xz should be replaced by gamma xz by 2. It is used to define state of strain at a point, that is just now whatever the conclusions I made for stress analysis now. Just now I made written the conclusion for the stress analysis. Everything is valid for the strain now. Stress tensor is what you have written now. Stress tensor is what you have written now. Square and symmetric matrix. Similarly, strain tensor is also square and symmetric matrix. Complementary shear stress are equal and like. Same thing what now? Complementary shear strengths are equal and like. That is gamma xy equal to minus of gamma yx. Gamma xz equal to minus of gamma zx. but we don't have all the proofs now. But if you want to get the derivation of all this thing, only this is going to be studied. Whoever is going to do the MTech in design, whoever is going to do the MTech in machine design, or MTech in stress analysis, advanced mechanics of solids, there you are going to do it. But timing here directly we are going to write down now. So strain analysis same as about the stress analysis. All the conclusion I am not writing directly, you can write down everything, whatever I written the conclusion, all these things. Strain tensor can be written similar to stress tensor, that is normal stress to be replaced by corresponding normal strain. Means that is sigma x by epsilon x, sigma y by epsilon y, corresponding normal strain. And shear stress be should be replaced by shear stress to be replaced by half of the corresponding shear strain. Half of the corresponding shear strain. Along the diagonal, what you have taken a normal stress sigma x, sigma y, sigma z. Now, what change you have to make it now? Sigma x should be replaced by epsilon x. Epsilon x, epsilon y, epsilon z, epsilon x, epsilon y, epsilon z. And first row is going to be what now? First row is representing stress on x phase. Now here representing on x strains. Now what you write down here now? In place of tau xy, you should write down the gamma xy by 2. Sir, why means we are going to discuss the shear strain. We have studied the normal strain definition yesterday, longitus strain, lateral strain you have studied. But shear strain you have still not yet discussed. For that one, we need the shear force concept is required. That afterwards I am going to discuss now. Timing you try to remember it. Why you are going to get it after discussing the shear strain concept is clear now. And this is what now? Here what you had write down now? Here I had write down the gamma yx by 2. But once again complementary shear strengths are equal unlike. Actually I had write down the gamma yx by 2. But complementary shear strengths are equal unlike. Here gamma yz by 2. Here what should I write now? Gamma zx by 2. But gamma zx and gamma xz are going to be same. Simply stress tensor should be symmetric. Here you have write down the gamma zy by 2. But gamma zy is equal to gamma yz. So once again the what now is a symmetric. This is what representing the suppose I am getting only diagonal elements are there. This is 0, this is 0, 0, 0, 0, 0. Suppose the matrix is given, only diagonal elements are there. What I have to call it now? If this is 0, this is 0. What you can call this now? Principal plane. What the principal plane you have studied, on that plane shear stress 0. Suppose these two are 0. Then directly this row will become as about a principal plane. Then directly this will become as a principal strain. Principal strain. Now this is 0, this is 0, this is 0. Means automatically these three are 0. Only you are going to get it epsilon x, epsilon y, epsilon z. So directly what now? This row will become as a principal plane. Principal plane. Principal plane. Then directly these are become as about a principal strains. Principal strains. What the principal stress you have studied now? Principal stress are the normal stress on the planes of zero shear stress. Principal stress are the normal stress on the planes of zero shear stress. Similarly, what the principal strains now? Principal strains are the normal strains on the planes of zero shear strain. On the planes of zero shear strain. If a matrix is sometimes they are giving only matrix, diagonal elements are there. So directly the diagonal elements will give the principal strains. Principal strains. Principal strain is a normal strain on the plane of zero shear strain. On the plane of zero shear strain. Now same thing for 2D, biaxial. This is for triaxial. For 2D what you have to make it now? Now this will be called as what now? This is representing what? A strain tensor. 2D means what? A biaxial or plane strain. Plane strain. Plane strain problems are what? A plane stress problem means what? A 2D. Similarly plane strain. So this you can call the strain tensor for plane strain problems. Is a strain tensor for triaxial state of strain. Plane strain means once again it's going to be 2D. But what the difference between the good? This Vipul Yadav is given good. Answer is good. But what the condition for plane stress problem? What the condition you have studied now? One dimension should be very small when compared to other two dimension, and loading should be in such a way that stresses develop in the smaller dimension direction should be very small in comparison to stresses develop in the larger dimension direction. But plane strain problem what happens now? One dimension should be very large. For plane stress problem, one dimension should be very small. Other two dimensions should be very large. For plane strain condition, that is what now? Whenever you want to assume the triaxial state of strain, assume this is the triaxial now. If you want to assume the biaxial, that if you want to assume actual problem the triaxial, I want to assume the biaxial, then what the condition you have studied now? Stress in one of the directions are going to be very small in comparison to stress in other two directions. Same thing here also, about the strains in one direction should be very small in comparison to strains in other two directions. But there, what the condition you have studied now? For plane stress problem, what the condition now? Geometric and one dimension should be very small when compared to other two dimension, and loading should be in such a way that stresses develop in the smaller dimension direction should be smaller in comparison to stresses develop in the larger dimension. This now. But if you go for a plane strain, what change you have to make it now? Plane strain. That is the plane strain problem. These are the conditions for plane stress. But when you are going for a plane strain, what change you have to make it now? Geometry of the component or member should be in such a way that one dimension should be very larger. In place of smaller, what change you have to make it now? Very larger in comparison to other two dimensions. For the example now, generally dams. Dams are going to be what now? The length of the dam is so many kilometers are going to be there now. But width and height are going to be meters are going to be there. So when dimension is very large, when compared to other two dimensions, it is about a plane strain. Next here, what change you have to make it now? Loading should be in such a way that strains developed in larger dimension direction. Strains developed in larger dimension direction should be smaller in comparison to strains developed in the smaller dimension direction. For plane strain, this should be replaced by very larger in comparison to other now. The condition for plane strain. Two conditions, geometry and loading condition. And here once again loading should be in such a way that strains develop in smaller dimension direction. Strains develop in smaller dimension direction should be smaller in magnitude in comparison to in place of smaller, what change it right down now? This should be replaced by larger dimension direction. So these are the conditions for plane strain. But most of the machine component case, plane stress possible. Plane strain generally are not going to come across in the machine components now. Condition for plane strain problems. Condition for plane strain problem. Wherever the stresses, you write down the strain. And in place of smaller dimension direction, what should you write down? Larger dimension direction. And in place of larger, you have to write down the smaller now. Sometimes this is possible for MSQ questions, multi-select questions now. But till now these are generally possible. And what now? In the GATE examination, one time is given a question is what now? Plane stress condition is given now. Okay, metal cutting also they are mentioning one of the friend. Sir, in metal cutting we assume plane strain condition. Now I understood, sir, why it is good. Generally about the machine components not possible, machine design, and we generally are come across only plane stress condition. Production point of view as well as what a structural civil engineers when they are going to deal with the dams etc. What there you are going to get it. Production point of view is possible now. Now, what the conclusion I made it now? We are going to study the equation for what now? Stress analysis. But how to write down the strain analysis? Wherever sigma you have to replace by epsilon. Wherever sigma should be replaced by epsilon. And tau by gamma by 2. Tau by gamma by 2. Now, whatever the equation I am writing, biaxial equation I am writing. These biaxial equations are studied in which chapter now? Principal stress chapter. But directly I am writing this now. Biaxial stress analysis equations. Yesterday I written the normal stress equation on oblique plane. Yesterday I written the normal stress equation on oblique plane. Under uniaxial you are derived. Same thing for biaxial, directly I am writing for biaxial. Biaxial, how many independent components are there? 3. Remaining everything is correct, my dear friend, only. This is going to be same only. That's why you are neglecting. One friend is keeping about a smaller magnitude. That is the correct only. Only what a larger dimension should be in place of smaller, larger dimension. And in place of larger, small, this will remain same. That's why they are neglected now. Yesterday I written the normal stress and shear stress on a uniaxial case you have derived it. So this equation I am going to derive in the principal stress chapter, but directly I am writing. So why I am writing means what? You can directly write down the strain analysis also. Just now what you mentioned now? Strain analysis similar to stress analysis. If you know the stress equation, directly you can write down the strain equations. Biaxial case, how many independent component? 3. Uniaxial case, how many independent component? 1. So what the sigma and equation you got is sigma cos square theta. Sigma cos square theta. But there uniaxial, what the independent, what the size of the matrix? Only 1. But in biaxial, how many independent components? 3. Sigma x, sigma y, tau xy. So this equation you are going to get in terms of 3. Sigma x, sigma y, tau xy. Sigma x, sigma y, tau xy. One by 2 sigma x plus sigma y. So what the advantage of the equation now? How many how many unknowns are here now? Sigma x, sigma y, tau xy. So what the advantage of the equation now? We can find out the, if I know the stress on x and y phase, that is if I know sigma x and sigma y, most of the objective question directly they are giving sigma x, sigma y, tau xy. Directly stress tensor is given, otherwise matrix representation, otherwise graphical representation is going to be given now. So if you know this now what the advantage of the equation, now we can find out the normal stress on any plane by substituting the theta value. By substituting theta value. And what the other useful now? If you differentiate the equation and equate to 0, what you are going to get it now? Principal planes. What the principal plane you have studied on which normal stress is going to be what? Either maximum or minimum. So by differentiating the equation with respect to theta and equate to 0, we are going to get a principal plane. And what the other use of this now? By equating the equation to 0, we will get a plane of pure shear stress. What the plane of pure shear stress on which normal stress 0. So what the use of this equation now? By substituting the various values of theta. Plane to plane, what happens now? Theta will change. By substituting the different values of theta, we can find out the normal stress on any oblique plane under biaxial or triaxial now, biaxial. And what the other one now? If we differentiate the equation, but generally you are into the maximum normal stress. Now if you differentiate the equation with respect to theta and equal to 0, you are going to get a principal plane location. That is what now? Where the normal stress maximum or minimum. Yesterday I have given the method I have given, but this is the equation. And what the other use of this now? If I equate the equation to 0, you will get the location of 0 normal stress. 0 normal stress means that is nothing but a plane of pure shear stress. Plane of pure shear stress determined by equating sigma and equation to 0. Now if you know this now, can you write down the strain equation now? If you know this now, can you write down the normal strain at an angle of theta? Normal strain at an angle of theta. What change you have to make it now? In place of sigma x, epsilon y, epsilon x, epsilon y, here gamma xy by 2. So what the normal strain equation at an angle of theta? 1 by 2 epsilon x plus epsilon y, 1 by 2 epsilon x minus epsilon y, cos 2 theta, gamma xy by 2 sin 2 theta. So the epsilon n equation is a compulsory optional. If you know this equation has to be remembered always now. It is a very, very important equation now. If you know this equation, the normal strain equation oblique plane is going to be optional. Now similarly what now? Shear stress equation. How to get the shear stress? If you know the equation, second equation directly can write down now. What change you have to make it now? Make the first term as 0. And second term, what change you have to make it now? In place of plus minus. And what the third change now? Sin and cos should be interchange. Don't try to by heart each and every equation. Your inverse examination, you can by heart each and every equation. Here, try to remember which are compulsory now. Try to remember all now, but try to remember the which are compulsory now. This epsilon sigma and equation compulsory. Now tau s equation optional. If you are able to remember, well and good. Otherwise, but this is a compulsory. If you know this equation directly can write down now. What change you have to make it now? Make the first term as 0. Suppose if you don't remember this now, if you want to derive, it will take some time now. But I am going to derive in the principal stress chapter now. But this is a compulsory. This is equation optional. If you are able to remember, well and good. But this is optional. What if you know this equation? What change you have to make it now? Make the first term as 0. What is the second change now? In place of plus, it is a minus. In second term, what change you have to make it now? In place of plus, minus. And what the third change now? Interchange the sin and cos. So what the tau s equation now? Minus 0. Minus 1 by 2. Sigma x minus sigma y. Sin 2 theta and tau xy cos 2 theta. Now what is the use of this equation now? Now you can find out the shear stress on any plane by substituting the theta. And what the other equation, what the other use of this equation? If you equate this equation to 0, you are going to get a principal plane. So how many ways the principal planes are located? We have studied yesterday now. Two methods, either equating this equation to 0, differentiating and equate to 0, or this equation to be 0. And what the other use of the equation? You want to get a Tomax plane, what do you have to do it now? If you differentiate the equation with respect to theta and equate to 0, you will get a Tomax plane locations. Now once you know this, now can you write down a shear strain equation now? Can you write down a shear strain equation oblique plane? Wherever tau, what I have to do it now? Wherever tau, you have to replace it by gamma by 2. So what the shear strain equation at an angle of theta? Shear strain equation at an angle of theta. In place of tau, what should I write now? Gamma s by 2. Gamma s by 2. Minus 1 by 2. Epsilon x minus epsilon y sine 2 theta gamma xy by 2. Then 1 by 2 on either side will get cancelled out. So if you know the equation, first equation if it's remembered, second equation directly can write down. Now directly I am writing the principal stress equation also. How to get a principal stress equation now? How to get a principal stress? Yesterday I have clearly mentioned how to get a principal stress now. Equate this equation to 0. What the principal stress now? Principal stress are the normal stress on the plane of 0 shear stress. Principal stress are the normal stress on the plane of 0 shear stress. Then how to get a plane of 0 shear stress? First equate this equation to 0. Then you will get a principal plane location. Then what the principal stress? Normal stress. Now whatever the value you are getting theta, that you have to substitute in this now. So directly I am giving the equation. So what the actual method now? If anybody want to get it, what do you have to do it now? Equate the equation to 0. Get a value of theta. That theta value you have to sub. If you equate the equation to 0, you are going to get the two values of theta. How many principal planes are there in the biaxial case? 2. How many principal stress are there in the biaxial? 2 non-zero principal stress. Then you are going to get the two values for theta. And what the angle between the theta? 90 degrees. If I am equating 0, one value I am getting 30, other one will be 120. Now how to get a principal stress? Principal stress is a normal stress on the plane of 0 shear stress. Equating through 0, I am going to get a location of 0 shear stress plane. Once you get the value of theta, you substitute it now. Then you will get the equation. So directly I am writing this is a very, very important equation now. 1 by 2. So many objective questions on this now. So this better to remember. Second equation optional. First is compulsory. This is compulsory. But somebody will ask how you got it, mean what the answer now? Either differentiate the first equation and equate to 0 or equate the second equation. Then you are going to get the two values of theta. And that value of theta you have to substitute in this now. Now can you write down the principal strains now? How to write down the principal strain? Principal strain mean what? Principal stress are normal stress or shear stress? Normal stress. Then automatically principal strains are the normal strain. So what change you have to make it now? Epsilon 1 comma epsilon 2. Epsilon 1 comma epsilon 2 equal to 1 by 2 epsilon x plus epsilon y plus or minus square root of epsilon x minus epsilon y whole square plus 4 gamma xy by 2 whole square. So once you know this, now strain equation directly can write down. Wherever sigma, you have to replace it by epsilon. And wherever tau, you have to replace it by gamma by 2. That's all. So what the principal strain equation now? 1 by 2 epsilon x plus epsilon y plus or minus square root of epsilon x minus epsilon y whole square plus 4 gamma xy by 2 whole square. And if you can add these two equations, what you are going to get it now? Yesterday what you have studied, sum of the principal stress. Sum of the principal stress is what now? Sigma x plus sigma y. If you add these two equations, you are going to get it sigma x plus sigma y. And yesterday I written what now? We got the normal stress at an angle of theta. And what the sum of the normal stress at an angle of theta and 90 plus theta. How we got it now? Normal stress at an angle of theta plus normal stress at an angle of 90 plus theta. How much you got it now? Sigma x plus sigma y. How we got that relation from this only? We got the normal stress at an angle of theta. Then how to get the normal stress at an angle of 90 plus theta? In place of theta, substitute the 90 plus theta. So what about this now? Cos 180 plus 2 theta. What the cos 180 plus 2 theta minus cos 2 theta? What the sin 180 plus 2 theta minus sin 2 theta? Now add these two equations. This is one equation. Then how to get the sigma at an angle of 90 plus theta? That is on the complementary plane. So here this will become as what a cos 180 plus 2 minus cos 2 theta. Is a minus sin 2 theta. Then add these two equations. You are going to get it what now? Half sigma x plus sigma y plus half sigma x minus sigma y. It is equal to sigma x plus sigma y. This is very important. You have studied yesterday now. Complementary normal stress are what now? Maybe equal, maybe unequal, maybe like or maybe unlike. Somebody will ask now how you got this relation. What the answer now? In the equation 1, in place of theta, substitute the 90 plus theta. In equation 1, in place of theta, substitute 90 plus theta. Then this term overall will become as a minus. This term is also become as minus. Cos 180 plus 2 the minus cos 2 theta minus sin 2. Add this 2 now. What happens now? If I add the first sigma equation at an angle of theta plus sigma at an angle of 90 plus theta, we are going to get sigma x plus sigma y. That's why what you have studied now, these two are equal unlike only when now. These two are equal unlike only when sigma x plus sigma y 0. Complementary normals are equal unlike only when sigma x plus sigma y 0. Similarly what now? And you have written yesterday now. Tau s at an angle of theta. Tau s at an angle of 90 plus theta. Just now already proved it also. Complementary shear stress are equal unlike. Once again, how we got this relation? In this equation, substitute 90 plus theta. If we substitute 90 plus theta, this will become as what now? Minus sin 2 theta. This is minus cos 2 theta. If you add the what now? Tau s at an angle of theta and tau s at an angle of 90 plus theta, you are going to get 0. That's why always on two perpendicular planes, shear stress are equal unlike. That is what now? Complementary shear stress are equal unlike. But normal stress are maybe equal, maybe unequal, maybe like, maybe unlike. But they are equal unlike only when now? Only when these two are equal unlike. When sigma x plus sigma y 0. So always on two perpendicular planes, shear stress are equal unlike. But normal stress may be equal, may be unequal, may be like or may be unlike. But their complementary normals are equal unlike only when sigma x plus sigma y 0. Now strain also you can write on the same. What the strain you can write on? Epsilon at an angle of theta. Epsilon at an angle of 90 plus theta equal to epsilon x plus epsilon y. gamma s at an angle of theta, gamma s at an angle of 90 plus theta, it is going to be 0. Sorry. But these equations are derived for this case now. Now these equations are derived by assuming the state of stress. Textbook to textbook, these equations are changes because the assumed state of stress is different. I derived this equation by assuming the state of stress. Now you can take and see it now. Tau xy you are taken clockwise, anti-clockwise. Tau xy downward. So this one and this one will form a couple in which direction? Now clockwise. Clockwise. And here you can see it now, this tau s on an oblique plane. Is it what anti-clockwise, clockwise now? This tau s is give a couple in clockwise, anti-clockwise. How to decide the clockwise, anti-clockwise? You have studied yesterday. For this one you have to consider a plane, parallel plane above. Is a one triangle. So you are going to get the other part is above. Here upward means other one downward. Yesterday when you have shown the uniaxial state of yesterday morning I have shown it now. How to decide the clockwise, anti-clockwise? First draw this triangle. Then you are going to get the another part of the square above. So here upward means other one you are getting a downward. Now these two are going to get a couple in anti-clockwise direction. So while deriving the equation, what I consider now? This is a tau xy. This is a tau xy. Tau xy is clockwise, anti-clockwise, clockwise. But tau s is going to be anti-clockwise. Tau s is going to be anti-clockwise. And theta is measured from which phase now? X phase. Theta is measured from X phase in clockwise. How we got this equation now? We are going to consider equilibrium of this triangular element. Equilibrium of this triangular element. Then you have to resolve the forces. First you have to convert the stress into force, then you have to resolve it. How to decide what now? Is a clockwise, anti-clockwise, what you have studied now? This is what now? X phase. This is, it is the tau xy, tau yx, tau xy. This is tau yx. So while deriving the equation, I don't know this direction. I have assumed this is upward. I have assumed it. Now upward, I have assumed it. Now this is a clockwise, anti-clockwise. How to decide this is a clockwise, anti-clockwise? Now yesterday I studied. Now always on two parallel planes, thus are equal and opposite direction. For this one, where you are going to get a parallel plane above, draw the remaining part of yesterday I only drawn it. Now draw the remaining part of the square. Now where you are going to get the remaining part of the square. The remaining part of the square now. So this is a clock. This is what the theta. This is how much is now? 90 minus theta. 90 minus theta. Always you are measuring from which face now? X face means vertical. This will be what na theta. Everybody is going to get a doubt now. Sir, the clockwise, anti-clockwise, how do you know, sir? I'm going to always keep the arrowhead towards the oblique plane. Always somebody is going to keep it what now? Sir, the anti-clockwise, sir. They are going to keep it like this. Sir, you are mentioning is a clockwise, sir, but the anti-clockwise, sir. Always theta should be, direction of arrowhead should be towards the oblique plane. This is your reference. This is a reference. So always arrowhead should be kept towards the oblique plane. Don't keep it like this. Is incorrect now. Most of students are going to ask the doubt now. They'll keep it like this. Then they'll go the anti-clockwise. So always arrowhead should be towards the oblique plane. Here also you can see it now. This is the oblique plane. Now you can see this plane is inclined at what angle? Theta from X face. That is the vertical line, clockwise. And this is also what now? This is also oblique plane. Both are parallel. It is also inclined at the same angle. So what the assumed direction of tau s? This is the upward, this is the downward. Now these two will form a couple in anti-clockwise, clockwise, anti-clockwise. And here tau x5, this is tau x5. Here you are going to get upward. So these two will what now? Clockwise. This will be what a tau x5. X face y direction. So only should be careful what now? What should be the careful here now? While whoever is using the equation, whatever the equation are written on the board, whenever you are using the equation, we have taken normals to the tensile or compressive? Tensile. So by chance is given what a compressive should be taken as negative. While deriving this one, you have taken tensile. In the question is also given tensile mean positive. So by chance is given as a compressive, then it should be taken as a negative. So what the sign convention for normal stress? Tensile is positive and compressive is going to be negative. After solving this now, I am getting this value is negative. Suppose theta is given in the question now. Theta is given some 30 degrees now. But after some in the question which is given, sigma x is given, sigma y is given, tau xy is given. Sigma x is given, sigma y is given, tau xy is given. Now I am going to substitute. Theta is given 30. I am getting a positive value, mean my assumed direction is correct. My assumed direction is tensile. What I have taken is a tensile. So I am getting a negative. Negative mean my assumed direction is incorrect. Then it's going to be compressive. My negative direction is what? I am getting a negative means my assumed direction is going to be incorrect. Means be like this. Then it is going to be a compressive. So what the sign convention for normal stress you are taking now? Tensile is positive and compressive negative. And what the tau xy sign convention now? Tau xy sign convention is what now? Clockwise. These are taken downward, the upward. Is assumed only. Actual directions are depend upon the load now. So without knowing the load direction, we cannot decide it now. Maybe a tensile or maybe a compressive, depend upon the load now. So I have assumed this is going to be a tensile, this is going to be a clockwise I have taken. And what the direction of this tau I have taken? Anti-clockwise. So textbook to textbooks. Some textbook they are taking the theta with the y phase. In another textbook they are taking theta with the y phase. And for another textbooks, Timoshenko and Gere is going to take the theta the anti-clockwise direction. Even made the strength of material book, they has taken the theta the anti-clockwise direction. And some textbook they are going to consider the upward, they are going to consider now. You can use any equations, but you should remember the assumed state of stress. So whatever the equation are derived, assuming the state of stress. What is the state of stress now? Normal stress here taken tensile. Means if they are also given as a tensile means a positive. If I am given as what a compressive means it should be taken as a negative. And tau xy means vertical shear stress. This is a tau xy. What about these two? No, tau yx. It is going to be a anti-clockwise. Your equation here getting tau xy, tau yx, tau xy. So what the tau xy means what? What is the meaning of tau xy? X phase y direction. This is the x phase y direction. So this is what? Vertical shear to the directly tau xy. Vertical shear to the tau xy. So what these two are forming now? Forming a clockwise. Suppose they are given in upward direction means anti-clockwise negative. So what the tau xy sign convention now? When they are forming a couple in clockwise direction is positive, anti-clockwise direction is negative. And what the tau s direction now? Anti-clockwise direction. So after calculation I am getting the positive. What is the meaning of positive now? Assumed direction correct. What is the assumed direction now? This direction. But this direction is what now? Giving a couple in anti-clockwise, clockwise, anti-clockwise. But I am getting a negative. I am getting a negative value after calculation. What is the meaning of negative now? Assumed direction is incorrect. Means a downward. Assumed direction is incorrect. Means downward. Then the upward. Either downward, the upward means they will form a couple in clockwise. So when I am getting a positive means my assumed directions are correct. If I am getting negative means assumed direction is going to be incorrect. Next theta. In our case theta you are measuring from which phase? Now x phase. Theta you are measuring from x phase in which direction now? Clockwise. Now write down this now. Sigma x may be greater than sigma y, we don't know. Sigma x may be greater than sigma y, may be equal, we don't know. Need not be sigma x is greater than sigma y. Mr. Anurag, we don't know sigma x may be greater or sigma y may be greater, we don't know. Now write down here now. Following sign convention. Following sign convention is to be used. 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 In equation 1 and 2. Following sign convention is to be used in equation 1 and 2. Equation 1 and 2. Number 1. Tensile normal stresses. Tensile normal stresses should be considered as positive. वो यूनिएक्सियल केस में लिया था. Because there is only one force is there. Only one load is there, axial load is there. If you resolve this, what component, what you are getting now? Component upward is there. In case of uniaxial case, I taken the downward only. Because there we are derived it because only axial load is there. If we I not taken that now. That is, if we resolve that axial load with respect to oblique plane, what you got it now? The shear component you got it upward, then resisting shear force are downward. That's why I taken now. But here what now? We don't know loading condition now. That's why you assumed it now. In uniaxial case, I not assumed now. Uniaxial case, I not assumed. That is about now. You see that we are derived that equation now. Axial load on an oblique plane. If you resolve it, what happened? Normal component upward, shear component upward, you got it now. Then resisting shear force at downward, you got it. That's why stress is what? A shear stress at downward, you got it now. Tensile normal stresses. Tensile normal stresses should be considered as positive. Tensile normal stress should be considered as positive. Tensile normal stress should be considered as positive. And compressive stresses. Compressive stresses should be considered as a negative. Compressive stress should be considered as negative. Compressive stress should be considered as negative. Next. Next. Shear stress on X face. Shear stress on X face. Shear stress on X face or vertical shear stress. Some students are unable to identify still shear stress on X face. Shear stress on X face or vertical shear stress. Vertical shear stress, that is tau xy. That is tau xy should be considered as positive. Should be considered as positive when it forms a couple in clockwise direction. When it forms a couple in clockwise direction. when it forms a couple in clockwise direction. And vice versa, and vice versa, and vice versa. Vice versa means anti-clockwise should be taken as a negative, and vice versa. Next, shear stress on oblique plane. Number 3, shear stress on oblique plane. Shear stress on oblique plane. Shear stress on oblique plane. That is shear stress on oblique plane, that is tau s. Shear stress on oblique plane, that is tau s, should be considered as positive. Should be considered as positive when it forms a couple in anti-clockwise direction. When it forms a couple in anti-clockwise direction, and vice versa. When it forms a couple in anti-clockwise direction, and vice versa. So you should be careful. For shear stress, two different. On x phase, when the tau xy is positive when clockwise, but shear stress on oblique plane is positive when anti-clockwise. So there is slight, should be careful now. Tau xy is positive when forming a couple in clockwise. These two. But these two are positive and anti-clockwise. Sir, I want to consider this also going to be clockwise, sir. Then you derive the equation as per that now. You can derive the equation as per it now. Next, inclination of the oblique plane. Inclination of the oblique plane. Inclination of the oblique plane. That is theta. That is theta. Should be considered as positive. Should be considered as positive. Should be considered as positive when it forms a couple in, sir, 1 minute, sorry, small correction. Inclination of oblique plane within bracket, that is theta, should be considered positive when it is measured in clockwise direction. When it is measured in clockwise direction from x phase. When it is measured in clockwise direction from x phase. Sometimes they are giving like this now. What should I take this now? This should be considered what now? Plus 30 or minus 30? Minus 30, because we are taken clockwise. But this given in what? Anti-clockwise given. Either you can take minus 30 or what the other angle you can take it now 150. Somebody can put it minus 30 because opposite or assumed direction. Otherwise, if you want to take the clockwise direction, what about this value now? 150. So either you can put it, what the theta I have to put it now? Either minus 30 or 150. Anyone you can take it now. Since the anti-clockwise opposite to assumed direction, minus 30. This is as per our direction, 150. You put it anyone, you are going to get the same. Sometimes they are giving like this now. This is what now? It is given with y phase, but we want x phase. Then what the theta value now? So theta will be what now? 60. Plus 60 or minus 60? Plus 60. Clockwise. Clockwise. Some question they are giving like this now. In this case, what the theta now? Theta should be measured from which face now? X face. X face means in our case vertical line. So this angle now. So this is 30. So here theta is about a plus 30 or minus 30? Minus 30. Because anti-clockwise. Anti-clockwise. Otherwise, if you want to measure in the clockwise direction, minus 30 or 150 can substitute it now. Always blindly remember what now? Arrowhead should be towards the oblique plane. Arrowhead should be towards the oblique plane. Everywhere you can see now the arrowhead I am keeping towards the oblique plane. They will not see all this thing. Sir, I is a clockwise, sir. I am kept it like this, sir. I am getting plus 30, sir. We are indicating the inclination of the oblique plane. We cannot keep it like this now. So always arrowhead should be towards the oblique plane, not X face. Everybody remember the equations, but they will not forget about the, they'll forget about the sign now. Those who are using my equation, you have to follow this sign convention. Inclination of the oblique plane. Inclination of the oblique plane. Somebody is asking to repeat the fourth one. Inclination of the oblique plane. That is theta. Should be considered as positive. Should be considered positive when it is measured in the clockwise direction from X face. Clockwise direction from X face. Mostly, most of the students are going to make a mistake in theta. Otherwise, this towards direction. Yesterday also we have discussed this now. Only should be careful the tau xy and tau s. Tau xy is positive. These are assumed direction. These are the assumed direction. But these two are what now? Giving a couple in clockwise and anti-clockwise. This downward and this upward is forming a couple in clockwise. So with this given as what now? By chance is given upward, means it will give a couple in anti-clockwise, the opposite direction negative. Now after my calculation, shear stress I am getting a negative. Shear stress I am getting a negative, means my assumed direction is incorrect. I am getting a positive, mean what? These are the assumed direction. I am getting a negative. Negative mean my assumed direction is incorrect. Then it is going to be a downward. Then here upward. Now this will be a clockwise. So shear stress on oblique plane is positive. Positive when it is forming a couple in anti-clockwise direction. Clockwise direction is negative. So shear stress sign convention on X face and oblique plane is different. Shear stress on X face and oblique plane is going to be different. Okay. Now, whether this equation useful for whatever I written, this is valid for biaxial, triaxial or uniaxial. This equation valid for biaxial, triaxial or uniaxial. They are not valid for triaxial. Triaxial is going to be complicated. Why no? Here how many independent components? Only 3. 1, 2, 3. But triaxial, how many independent components are there? No, 6. So triaxial is not as per the syllabus now. If you go for a triaxial, that is going to be studied in the MTech level now. Triaxial is studied in the MTech level. That directly can leave it now. It is not as per the BTech. Triaxial is very complicated. That is going to be do it in the MTech level now. But some of the universities BTech, very few universities. When I worked as a faculty in our college now, we are used to advanced mechanics of solids also we are introduced now. Final year. We enter the second year, one mechanics of solids, but final year we are introduced about the advanced mechanics of solids. There you also discuss the triaxial also you discuss. Similarly, some of the universities, very few universities, they are going to discuss the triaxial. But as per the BTech, so as per the GATE syllabus and engineering service syllabus, we are having only biaxial stress analysis. Triaxial is not there, blindly can leave it now. But those who are going to the MTech in design, there they are going to study further now. But can I use it for uniaxial? You can use it. Always higher order equation useful for the lower order. Similarly, if a student is thorough with the triaxial, then biaxial equations are simple, sir, compulsory, optional now. If you know the triaxial equation, biaxial equations are optional. Why? When the triaxial will become the biaxial, triaxial, how many independent components? 6 now. Sigma x, sigma y, sigma z, tau xy, tau xz, tau yz. So if you know the triaxial equation, how to get a biaxial equation? Make sigma z 0, tau xz 0 and tau yz 0. Biaxial, how many independent components? 6. Sigma x, sigma y, sigma z, tau xy, tau xz, tau yz. So if you know the triaxial equation, you want to get a biaxial, what do you have to make it now? You make the sigma z 0, tau xz 0 and tau yz 0. Similarly, now we are derived for biaxial, but triaxial equations are difficult to remember it. That's why they are going to use the form of matrices. Matrices are going to be used now. But biaxial equation can be used for a uniaxial. When a biaxial will become a uniaxial, how many independent components? Only one, sigma x. But biaxial independent components are 3. Sigma x, sigma y, tau xy. So I want to use it for uniaxial. What I have to make it now? Make the sigma y and tau xy 0. So yesterday, whatever you have derived now, day before yesterday, uniaxial equation, that equations are optional. Those you want to remember, you can remember, because I derived it what now? To introduce the concept of the principal planes, that is what the tau max plane, easy to explain that concept now. That's why I derived it, I given the definition of principal plane and tau max plane. But here what now? I cannot what now? Explain that concept now. The student has to remember only. So for the easy understanding of the principal plane and tau max plane, the uniaxial equations are better now. But with the equation without numericals, I cannot explain it now. That's why I introduced the concept of the principal plane and tau max plane with a uniaxial state of stress. Now finally what now? If you remember the equation, uniaxial equations are optional. Final exam now. Sir, shall I use that equation? Use this only because these are compulsory. If you know this now, directly can get a uniaxial. For uniaxial, what I have to make it 0 now? Make the sigma y 0, tau xy 0. So this term will become 0. And this term will be what? A sigma x by 2. Sigma x by 2 cos 2 theta. Then what you are getting now? Sigma x by 2 plus sigma x by 2 cos 2 theta. Then you are getting what now? If I take out the sigma x by 2 as common, what you are getting now? 1 plus cos 2 theta. What is the 1 plus cos 2 theta? 2 cos square theta. So sigma x by 2 into 2 cos square theta, you are getting sigma x cos square theta. And same thing here also what now? 0, 0. Then what you are getting now? Minus sigma x by 2 sin 2 theta. Sir, there you are written plus, you are written, sir. But here I am getting minus. Minus means what now? My assumed direction is incorrect here now. Minus means assumed direction incorrect, then it is going to be downward. If I am going to put the sigma y and tau xy 0, this term is 0, then I am getting what now? Everybody is going to, sir, your uniaxial and biaxial equations are differ, sir. It is not differ now. I am getting minus sigma x by 2 sin 2 theta. With the meaning, what is the meaning of minus now? Minus means my assumed direction is incorrect. Minus means I'm going to get a shear stress value is negative, I'm going to get it. Means my assumed direction is incorrect, then it is going to be a downward. That's why you got it what now? In case of uniaxial, you got it downward, you are taken, clockwise you are taken. If I put it negative means what is the downward? Is the upward. Now these two will form a clockwise. Now write down now. Above equations. So overall what now? If you remember the biaxial equation, uniaxial equations are optional. Uniaxial equations are optional. Write down now. Above equations can also be used for above equation can also be used for above equations also used for uniaxial state of stress. Uniaxial state of stress. By substituting sigma y is equal to 0. By substituting sigma y is equal to 0 and tau x, 1 minute slide correction. By substituting sigma y is equal to tau xy equal to 0. Sigma y is equal to tau xy is equal to 0 and sigma x is equal to sigma. Sigma x is equal to sigma. Because only one normal, so directly can write on the sigma. Now I can check it, you are going to get the same. This equation will become what as sigma by 2 cos 2 theta. Then you are getting, if I take out the sigma by 2 as common, you are getting what now? Sigma by 2 into 1 plus cos 2 theta. Then you are getting sigma cos square theta. But here you are getting minus sigma by 2 sin 2 theta. What the meaning of minus now? I am getting a negative value. Negative value means it is going to be a assumed direction is incorrect. Then the downward will be there. It is a downward will be there. Tomorrow I am also going to derive this so that what now this portion will be completed. Once again I am not going to discuss this one when you are going for the principal stress chapter. But timing I am not deriving, will complete the some questions. Now strain equation I not written now. That I am going to discuss separately, but if want those who want to, strain equations are optional. Strain equations optional, directly can write down now. Wherever sigma replace blindly by epsilon, wherever tau you replace it by gamma by 2. That's all. So that I am going to completely what I am going for the, but timing what now? The strain equations are optional. Principal strain equation, what the principal strain equation now? 1 by 2 epsilon x plus epsilon y plus r minus under root epsilon x minus epsilon y whole square plus 4 gamma xy by 2 whole square. But if somebody will ask how you got that principal strain equation, yesterday I have already mentioned now. How you got it means, and directly I have given the principal strain equation. If anybody how you got it means, first you have to equate the Taubes equation to 0, get the value of theta, and the theta values you have to substitute in. That I am explaining all now, but I am not doing. And the theta value you have to substitute in the sigma and equation. And this also I explain how we got it now. So we'll do the two questions. Right on the first. Out of all the friends, Mr. Swaraj Pandey is what now? Exciting a lot every day now. I'm going to be what very happy if my efforts are going to be what now useful. This sign convention, if check it now, no textbook you are going to get it. No textbook you are going to give it. They'll simply give the equation. But when a problem is given, they are going to be what now? Initially what now? When I joined the MEDI as a faculty in 2007 now, directly I gone for what now? Those who are not remembered this equation, then they have to go for resolving the forces. Those who are not thorough with the sign convention, then they have to go for the resolving the forces. When I am doing the resolving the force initially 2007 now, but most of students are not thorough with the resolving the forces. Then in the 2007 I have framed this sign convention. Otherwise, if you are not thorough with the sign convention, then you have to go for some question, you have to go for the resolving the force. You will get an answer, but it's going to be time taking now. Ready now? Which of the following figure represents biaxial state of stress at a point? Which of the following figure represents biaxial state of stress at a point? I am leaving some space for my explanation. Because extension I will take up the 3 or 4 questions, same thing now. First I am completing the objective examination. 4 figures are given. Identify the which of the following figures represent the biaxial state of stress at a point. So now can you give me now out of these 4 figures now, which is representing the biaxial state of stress at a point? It's a simple question. Almost 50% of the students give directly the correct answer. In one of the ESC paper is given, but 50% they are going to give incorrect now. Somebody is going to give A, somebody B, C, D. It is a MCQ question. MCQ question. Or even MSQ also what now? Only one answer is going to be possible now. Which of the following figure represent the biaxial state of stress at a point? Option A, Abhyuday Sharma. ABD, how ABD Mr. Rupesh Kumar. It is the MCQ question I mentioned now. Mr. Puneet Srivastava, how B is correct, my dear friend? Check the question properly. Lokesh Sinha, Puneet Srivastava, how B is correct? How D is correct, my dear friend? Raghav, B. Some students are what now? In hurry. They will not understand the question. Directly they will vote now. It is not a lottery game. Try to, it is not, your aim is not to match any one of the option now. In MCQ question, only one answer is correct. Everybody is giving B. How B you are giving, Mr. Sanjeev Gupta? Only answer A. Option A is correct now. Only option A is correct. What you have studied now? State of stress to be always in such a way the point should be under equilibrium condition. It is that biaxial or triaxial. Biaxial means how many conditions should be satisfied now? Some of the horizontal force should be 0, some of the vertical force should be 0, and some of the couple should be 0. Only option A. Remaining they are not in equilibrium condition now. One friend is given correct. Sir, directly you can tell option A, sir. B, C, D are not in equilibrium now. Somebody has selected D. How D is correct now? Is it equilibrium? Only in A. Some of the horizontal force 0. Some of the vertical force 0. Some of the moments are 0. Now can you write down the values now? If you ask this question now, can you find out the principal stress now? To find out the principal stress, what the values are required? Sigma x, sigma y, tau x phi. Now what the sigma x now? Okay, let me complete it. This is first now. Is it equilibrium or not now? Most of them are taken B now. Some students will not consider this A. Sir, sigma y is not there, sir. Sigma y need not be there. Biaxial mean what now? Stress should develop in 2 perpendicular direction or 2 perpendicular plane. This is the x phase. This is the y phase. This is in which direction now? Y direction. This is in which direction? X direction. Stress are developed in 2 perpendicular plane. X phase and y phase is there. Biaxial. Sigma y need not be there. But everybody is selecting this now. Sir, sigma x is there, sigma y is there. But your complementary shear stress is missing now. These two are forming a couple. These two are forming a couple in vertical plane clockwise. But where is the complementary shear stress now? Some of the couples are 0 or non-zero. Here non-zero. Here some of the horizontal force 0. Some of the horizontal force 0. Some of the vertical force 0. But some of the moments are not 0. Suppose we are complementary shear stress given. Now these two are what now? That only I proved it now. These two are forming a couple in clockwise direction now. But there is no anti-clockwise couple now. That's why clearly what I mentioned now. I written the conclusion also. Every shear stress to be associated with a complementary shear. Now you can see now. Every shear stress to be associated with a complementary shear. And at the junction there should be only one value. They should cross. They should cross. Blindly what now? Whenever the sum of the couple should be 0. What the condition now? They should cross. And junction only one value. Whenever what the complementary shear crosses which crosses and junction only one value. Sum of the couple. Here there is no complementary shear. So that's why some of the couples are not 0. So here which one is incorrect now? Which one is missing here now? Why it is not in equilibrium now? It is not in equilibrium because of what? A complementary shear stress is, that is tau. Yx is absent. Hence, sum of the couples is not 0. Here some of the horizontal, now you can see it now. They are not crossing. They are not crossing. And they are unequal in magnitude. But here which one is 0 now? Some of the horizontal force 0. Some of the vertical force 0. But some of the moments are not 0. Whenever the sum of the moments are coupled should be 0 means what now? They should cross. What is the meaning of now? They are not crossing means they are forming a couple in the same direction. These two are what now? Form a couple in which direction? Clockwise. And once again these two also forming a couple in which direction now? Clockwise. So whenever they will not cross, what happens now? They will not form a couple in opposite direction. And at the junction there are two different values. Either tau xy is 100, tau yx how much now? 50. What you have studied, whenever the complementary shear should be what now? Whenever the sum of the couple should be 0 means complementary shear stress should equal and unlike. How to check that condition now? Complementary shear stress are equal and unlike mean what you have to do it now? They should cross and at the junction only one value. So whenever the sum of the couple should be 0, complementary shear should cross. And at the junction only one value should be there now. So here which is what the incorrect now? In this case which is incorrect now? Direction and magnitude of is incorrect. Hence sigma m is not 0. That's why clearly I proved it also. Whenever the sum of the couple should be 0, they should be equal unlike. But how to check it equal unlike? They should cross and the junction there is only one value. Here some students have selected one this also. Here sigma h is 0. Sigma v is 0. Sir, sigma h is not 0. Sigma v is not 0. Sigma m is 0. These two are unequal or equal? Unequal. Either towards right side 100, towards left side 200. There, here which is the incorrect? No, magnitude of sigma x incorrect. Magnitude of sigma x incorrect. And but the incorrect now? Direction of sigma y in both are in what? Same direction now. Always for equilibrium what is required now? Same magnitude, opposite direction is required. Same magnitude, opposite direction required. So in this case, direction of sigma y and magnitude of are incorrect. Good. Some friends have given with explanation also. Sir, only option A, that directly, sir, only option A is correct because there is equilibrium. That's why I tried to what now? Focus the lecture is going on. In my mobile phone, if I am going to give a break now, there may be what now? Thousands of messages will be there from student, my friends, relatives, there would be, but I am not focusing on that now. I am focusing on my goal. My goal is only to satisfy my students and what now? Satisfy my students. I have to deliver the concept with a, I have to deliver my lecture so that all the students, their concept should be cleared. Somebody is going to review the notes. They will review the notes just like a newspaper. Don't review my class notes just like a newspaper. In newspaper, what you are going to do it now? Who is interested in the sports, they will go through only sports page thoroughly. Remaining all are, they are going to see the headlines, they are going to see it. And your parents are going to be there. Suppose your father is there. He is a business person, he is going to show only the business magazine, business page he is going to see. And somebody's parents are what a political is going to be there. They are going to say only political now. That page they are going to focus. Remaining what? Just like we will go a glance. We will see the headline, then we are going to leave it. But here, each and every point, whatever I am discussing important, please go through the class notes thoroughly, each and every point. And even when the lecture is going on, whoever is going to be focused when the lecture is going on now, that 7 hours lecture notes can be reviewed 1 hour thoroughly, sufficient now. Then you can utilize the time for practicing the questions. But if you are not focused during my lecture, 7 hours now, for 7 hours of notes now, you need the 10 hours time is also not sufficient now. So try to behave like a smart person now. Try to do smart work. When the lecture is going on, completely focus. If you are focused, then you can review your notes within 1 hour or 2 hours maximum. Then you can utilize the time for practicing the questions. Otherwise, simply just like a what now? Attending the mobile phone, attending the social media. Then if you are going to be what now? Just like a time pass, since I joined what made easy, I have to attend the lecture. In that case, for 7 hours of lecture to review your class notes, 10 hours is also not sufficient now. Now, can you make all are going to be biaxial state of stress? Can you make all are the biaxial state of stress? Now, how to make this a biaxial state of stress? Biaxial state of stress means sigma m should be 0. Now, you introduce the complementary shear stress. Now, it is correct. Now suppose if the options are given like this, now this will become an MSQ question. A is also correct, B is also correct, B is also correct. Now draw the separate figures now, draw the separate figures. It is also biaxial. Suppose the options are given like this, it will be A and B, both are correct. It is a MSQ. Next here, what change I have to make it now? What change I have to make it now? Direction of complementary shears, they should cross now. They should cross. And at the junction, only one value is required now. Now it is also equilibrium. This is example for pure torsion. This is example for pure torsion. This is called the pure shear state of stress. Whenever sigma x plus sigma y 0, whenever sigma x plus sigma y is a pure shear state of stress. Pure shear state of stress. So C is also correct. Now if it is given like this, now A, B, C are correct. D is not correct now. Now here what change you have to make it now? Now this is 0. And this should be direction should be changed now. Now this is also biaxial. Biaxial means what now? Stresses should develop in two perpendicular direction or two perpendicular planes. It is also biaxial. Now this is an example for thin cylindrical pressure vessel. Thin cylindrical pressure vessel under internal pressure, longitudinal stress and hoop stress. Is a practical example. This is called as what this figure is called now. They are all biaxials. Now this is correct. Suppose the MSQ question is given. Now all are correct. A is correct, B is correct, C is correct, D is correct. So this figure is called as what now? Pure shear state of stress. Pure shear state of stress means that is sigma x plus sigma y 0. Sigma x plus sigma y 0. And what the practical example for this now? Shaft subjected to pure torsion. Pure torsion. Pure torsion. And this is example for what now? Thin cylindrical pressure vessel under internal pressure. Thin cylindrical pressure vessel. CPV. CPV means cylindrical pressure vessel. CPV means cylindrical pressure vessel under internal pressure, where sigma x is equal to longitudinal stress PD by 40. Sigma y is a hoop stress PD by 2T. That's why I have taken this value is double. I have taken now. IP means internal pressure. PD by 40. So this value is written as what now? Double of 2 times the longitudinal stress. I use the short form here. CPV, cylindrical pressure vessel. IP means internal pressure. L means longitudinal stress. H means hoop stress. Hoop stress. P the pressure, D the diameter, T the thickness. How we got it? This you are going to study the chapter number 9 now. Now for all these cases, what do you do it now? Find out the principal stress. For all these cases, now find out the principal stress. But in which case you directly know the principal stress? Directly in this case you know the principal stress. Your sigma 1, sigma 2 formula is required or not required? Just now I have given a sigma 1, sigma 2 formula. That formula is compulsory in which case now? ABC. But here is the optional. Directly what now? Either the principal plane. Out of ABC, in which case you know the principal plane? Only in this case. Yesterday I discussed now. So direct your sigma 1, some students are what now? They will remember the sigma 1, sigma 2 formula. Here also they will use it now. If you use that sigma 1, sigma 2 formula here now, you are a non-flywheel. You are a non-flywheel. Don't use the equation for every question now. Directly what the principal stress now? Sigma 1 200, sigma 2 100. That's all. But here we don't know principal plane. Is it a principal plane? It is not a principal plane. Here it is not a principal plane. Both normal and shear stress, this is a combined stress. What about A and B? A and B are the combined stresses. Combined means what? Both normal and shear is there now. So A and B's compulsory equations are required. But D is the optional. For all these 4 cases, what do you do it now? Determine the principal stresses. Now this you have to complete it. Determine on the oblique plane as shown in the figure. As shown in the figure. Next one, principal stresses. Now can you give the sigma x, sigma y values? Now what is the sigma x here now? Plus 100. What is the sigma y? 0. What about tau xy? Which one the tau xy? Tau xy means vertical shear stress. So these two are causing an anti-clockwise, clockwise. Anti-clockwise means negative. Minus 50. So remaining directly substitution only. Theta, how much I have to take it now? Minus 30. I have given all the values directly in the equation. Once again, find out the same question now. For all the questions, you complete this too now. For all the questions, you do it now, so that so many questions will be completed now. Once again, find out the normal and shear stress now. What the theta value here now? Theta is going to be minus 30. Now, can you give what the sigma x, sigma y, tau xy? What the sigma x now? Plus 100. What the sigma y? Compressive. Minus 200. What the tau xy? Tau xy means always vertical shear stress. Now these two are causing a clockwise. It's a plus 50. Because clockwise. So once again complete this two now. For all the questions I am giving this now. Complete the normal and shear stress, but theta is how much now? Theta is with y phase is given. Theta is going to be with x phase is what? 30. Here theta is minus 30. Here theta is plus 30. Now here what the sigma x and sigma y? Sigma x 0, sigma y 0. What the tau xy? What the tau xy? Plus 100. Tau xy is plus 100. For all these four cases, complete the both now. Such an oblique plane as well as principal plane. But here principal stress directly can get it now. You need the sigma 1, sigma 2 equation ABC. Sigma 1, sigma 2 equation required for ABC. D the optional. D the optional. $60. So here once again what now? Theta is what? A minus 60. Find out the normal and shear stress on all the oblique planes and find out the principal stress. But here principal stress are optional here now. So complete these four questions now. So complete these questions. Now I am going to give the workbook question for practice also. Only what now? You should do the numerical calculation. Everything I have done it here now. Only numerical calculations you have to do it now. This is about now you have to complete it chapter number 1. Question number 26 and 27. Everything I discussed in the class, whatever I discussed, only for that one, based upon this one, I am giving the question for practice. all objective exam directly they are giving the state of stress. If the state of stress given simple, no, problem is simple. Sigma x, sigma y. Only you have to remember the sigma and equation. And you have to do the proper sign convention. Here what is the sigma x now? Sigma x is plus 100. Sigma with 200. So directly they are the principal stresses. And tau xy 0. So when the sigma x, sigma y will become the principal stress, whenever tau xy 0, directly sigma x, sigma y will become the principal stress. So when x and y phase will become the principal plane, x and y phase will become the principal plane when tau xy 0. So sigma x and sigma y will become the principal stresses. Principal stress when tau xy 0. Chapter number 7. Question number 5, 4, 6, 8, 16, 22, 27 already completed yesterday. 34, 36, 39. So these questions you can complete it now. Directly now. So much of questions are going to be there. You have to complete this now. Objective exam, this is there. But how to find out the sigma x, sigma y, tau xy? In objective examination, directly these values are given. Sigma x, sigma y, tau xy will be given. Sir, but how to find out the sigma x, sigma y, tau xy? For that one, you need the load concept. So these are all objective point of view. Objective point of directly they are giving sigma x, sigma y, tau xy. Now tomorrow we are going to discuss the loading concept. I am going to discuss if how to find out the sigma x, sigma y, tau xy, that we are going to discuss. So try to complete almost 1, 2, 3, 7, 10 questions are there. These 10 questions as well as here what now? 8 questions. Almost 18 questions are there that you complete it now. Value of sigma y does not showing the logo. Sorry. So I am writing here sigma y will be hoop stress. Hoop stress is PD by 2T, which is equal to 2 times the longitudinal stress. Sigma y in case of thin cylindrical pressure vessel, CPV cylindrical pressure vessel under internal pressure, sigma x equal to longitudinal stress PD by 40, sigma y will be hoop stress PD by 2T, that is going to be 2 times the longitudinal stress. L means longitudinal, H means hoop stress. How we got it, that you are going to study in the chapter number 10, chapter number 9, sorry. So thank you my dear friends. Swaraj Pandey, thank you. So today's lecture is completed. You are having today so much of work is going to be there. You have to go through the class notes and questions are there. You can complete it now. So we'll continue tomorrow. So thank you one and all. So today's lecture now the recording will be stopped. And if any important queries, you can send your queries. So if it is a genuine queries, I'm going to respond it. So thank you one and all.